the three-dimensional geometry. So this is the fifth topic in Form 4. And the first lesson, we are going to learn the general properties of common solids. Before we go to three-dimension, we need to know the other dimension. So if we have figures here. This is a line. For a line, you can only find the length. So we call it one dimension. So a line is of one dimension. Here we have a rectangle. We can name it A, B, C, and D. For this rectangle or a plane figure, so this is a rectangle where you can find the area. So for figures which you find the area, those are plane figures, we call them two-dimensional figures. Two-dimension. This is a cuboid. For a cuboid, you can find the volume. You find the volume of the cuboid. It is a solid. Then, for any solid or figure where you can be able to find the volume, we call it three-dimension. Three-dimension. So that's this is the first dimension. One dimension, two dimension. One dimension is when you find the length. Two dimension is a figure where you can plane figure where you can find the area. That's two dimension. A figure or a solid where you can find the volume. It is a three-dimensional geometry. So that's we are going to deal with the three-dimensional geometry. So let's go and find some figures. These are some of the figures which you can be able to define the dimension. So this is a circle. You can find the area. So it is a two-dimensional geometry. Two-dimensional. This is a cylinder. You can find the volume. So it is three-dimensional. Three-dimensional geometry. This is a hexagon. This is a hexagon. We can. It's a polygon. We can be able to find the area, and therefore it is two-dimensional. Two-dimensional. I can say two-dimensional. This is a cone. A cone, you can be able to find the volume, so it is three-dimensional. So this is a pyramid. You can be able to find the volume, so it is a three-dimensional figure. Three-dimension. This is a line. You can be able to find the length. So it is one dimension, dimension. So these are some of the figures you can be able to describe their dimension. We are going to concentrate more on three-dimension, and in three-dimension you can describe the three-dimension in terms of vertices. Or you can call them points. For example, e.g. E, this one, that's a point. So that's a vertex. In singular, it's a vertex. When there are many, they are vertices or a point. We also describe the three-dimension in terms of edges. Edges. Or which we can call lines. For example, we have AB. We have AB. It is it is an edge, the one I have put in red, or we can put it like so. That's an edge. So that's an edge, and we can say EGAB. So that's an edge. We also describe 3 dimension in terms of faces. Faces or planes, which we can say planes, and we can give an example. An example of a plane is, for example, this one. That's a plane. So you can describe that's a plane, and you can say e.g. the one that I put in green, CDEH. So that's a plane. So that's how we describe solids in 3 dimension, or figures that are 3 dimension. So in this topic, we are going to discuss the relationship between lines, planes in 3 dimension. In this part, we are going to look at angle between a line and a plane. Now that we have said that in solid, we describe them in terms of vertices, edges, and faces, how do we get the angle between a line and a plane? I'm going to use a simple figure to describe that. So I'm going to draw a plane. This is a plane like that. So a plane which we can label. We can give it the label A, B, C, and D. From there, on this plane, we put a line that is inclined at a certain angle. So a line there in blue, which we can label. This line, we can label it PQ. So it is one end of the line is lying on the plane. So let's put it like that. So we have a plane ABCD, and we have a line PQ whose one of the end touches the plane at a certain angle. Then we will put a light here to shine on this line. So this is light. Because the line is inclined at a certain angle, it will make a shadow. It will make a shadow here because of the light shining on it, and that shadow we can put it like that. So that is the shadow of the line. Because the light is directly on top of the line P, or point P, we can drop a line there which will touch the shadow here. That shadow will make a right angle with the line that is dropping from P. So now line PQ, the angle between, so we can say the angle, between, so this point here we can call it R. So we say that the angle between QP and QR is the angle between between the line between the line QP and the plane A, B, C, and D. So if you are given So the angle between, this is the angle between the line QP and the plane ABCD. Then we say that QR is referred to as the projection of QP. That is, let's put that clearly, of QP. So QR is a projection of PQ, or in other words, we can say, if you take a line here, that is, we take PQ here, we take PQ. Okay, if you drop it like that, it will fall on its shadow. So the shadow is the one that we are referring to as the projection. So if you drop PQ like the way I'm doing here, you'll be able to get the projection. From there, we can conclude and say, we put a conclusion. We say, in general, we say the angle between a line and a plane is the angle between the line between the line and its projection on the plane. So that, I hope that is very clear, that the angle between line QP and plane ABCD is the angle between the line PQ or QP and its projection, which is QR. So this is the angle, we can call it angle theta. So to get the angle between a line and a plane, you get the angle between the line and its projection. From there, let's have a look at an example to understand it better. Our first example, we are told the figure below shows a right pyramid with a rectangular base ABCD. L is the midpoint of BC and O is the center of the base. So we have our figure here. Our ABCD is the base, O is the center, we have the vertex V, then we have L is the midpoint of, or the L is the midpoint of BC. We have our L here. So part A of this, we are told state the projection of each of the following. The first one, the Roman number 1, we are told VB. VB, this is the line, VD, not VB. VD is the line, is this line. So the projection of VD is OD. The projection of VB. This is to say, like we have said, if you draw a line here, if you drop it, it will fall onto OD. So the projection of VD is actually, we say it is OD. This is part A of the question. Roman number 2, we are supposed to get the projection of VA. Where is our VA? This is our VA. The projection of VA is AO. That is, we have said the projection is actually the shadow. So if you drop it, the line VA should fall on its shadow, which we are referring to as a projection. So we say the projection of VA is AO or OA. Can call it OA. We move to Roman number 3, and we say the projection of VB. Where is our VB? This is our VB. So the projection is where this line will fall. it will fall on OB. So the projection of VB is actually OB. So we have Roman number 4. We have VC. Where is our VC? This is our VC. So the projection of VC, can demonstrate it. It's where the line will fall onto. So it is OC. OC is a projection of VC. OC, like that. Then we go to Roman number 5. Roman number 5, the projection of VO. VO is this line here from the midpoint. So if you shine right here, you shine a right, the shadow of VO will be on point O. So the projection of that point is, of that line, is point O. So we say it is point O, like that. So that's how you answer that. So I hope you have understood the projection of a line on a plane. It is its shadow, or where that line, if you drop it, will fall onto. Part B of the question, state the projection of VB. Where is our VB? This is our VB on the plane that is VAC. So part B of the question, this is part B. We are told state the projection of VB. This is our VB on the plane VAC. So if you drop this line, where will it fall onto? We can demonstrate that by drawing a line there. Let's we draw a line here. So if you drop that line on the plane VAC, it will fall onto VO. So we say the projection here of VB on VAC is actually VO. That is Roman number 1. Roman number 2, we have VC on plane VBD. We have VC, this is our VC on plane VBD. So this means that if you draw a line here, if you drop it on this plane, it will fall on VO again. So also this is the projection of VC on plane VBD is VO. So that's how you answer that. We go to part C. Part C of the question. Let's say part C here. Name the two lines on the figure that are perpendicular to VO. Where is our VO? This is our VO. So if you can draw that, the two planes which are perpendicular, the two lines which are perpendicular to VO, we can see here AC, that is we are talking of part C. We have AC is perpendicular to VO. We have BD is also perpendicular to VO, and any other line that is on the plane ABCD. So we can say the lines which are perpendicular to VO, we can say AC. We can say AC. We can also say BD. That is BD, and any line on the plane ABCD. So any line on the plane ABCD is perpendicular to VO. So that's how you answer part C of that. We come to part D. Part D, name two planes which are perpendicular to BD. Where is our BD? This is our BD. We can use a line. We can draw BD. So any two planes which are perpendicular to BD, we can say one of them is VAC. That is V, that plane, and this plane. Okay, so that is a perpendicular. We can also say VBD. Also this plane also is perpendicular to BD. That is VBD, like that. That is that plane. So those two are perpendicular. We also have, we can also say this plane is also perpendicular at the center, and that is VOL, like that. So we have the planes which are perpendicular to BD, AVC, okay, or VAC. We have VBD and we have VOL. So those are the planes which are perpendicular to BD. So we can say VAC. We also say VBD and that is we has and VOL. Those are the planes which are perpendicular to VD. Okay, so that's okay. Let's clear the diagram. We go to part E. Part E, name the angle between VC and plane ABCD. Where is our VC? This is our VC, and the angle and the plane ABCD. So we said the angle between a line and a plane is the angle between that line and its projection. So we have said that the projection of VC is actually OC. So this means that the angle between line VC and plane ABCD is actually VCL, or VCO, not VCL, VCO. So angle VCO, that is the angle between line VC and plane ABCD. It is the angle between VC and its projection, which is OC. So that's how you answer that. Let's go to part F. Name the angle between. So we go to part F. Name the angle between the plane VCB. Where is our VCB? This is the plane. This is the plane VCB and VO. So this is like the angle between line VO and the plane. So what is the projection of VO on the plane VBC? So if you drop VO there, its projection is OL. So the angle between this plane is actually OVL. If you draw the projection of VC is that. So if you drop VC here, it should fall onto VL. So this is the angle that we are interested in. So the angle, that is angle OVL. That is the angle between the line VO and the plane VBC. And that's how you answer that question. So I hope with using this example, you have understood the angle between a plane and a line and a plane. It is the angle between that line and its projection. Let's have a look at the second example. Example 2, we are told the figure below shows a rectangular tank of length 8 meters, width 6 meters and height 4 meters. SB, so we have the length is 8 meters, the width is 6 meters and the height is 4 meters. SB, our SB is the diagonal of the tank, and T is that is SB. This is SB is the diagonal of the tank. and T is the midpoint of SR. We have our T here. Calculate. So we have our diagram. This is the tank. So it is labeled A, B, C, D, P, Q, R, S. T is the midpoint of SR. The length is 8 meters. The height is 4 meters. And the width is 6 meters. Calculate part A, the length of SB. So which is the SB here? We can draw a line here, SB. This is the SB. That is the line SB. It is the diagonal across from the bottom to the other side of the tank. Now, to be to be able to get SB, we need this line here. We need the line SC, because now here it is a right angle. So SCB is a right angle triangle. Therefore, we can be able to use the Pythagoras theorem. But we don't know SC. So what we do is we use SR and SC, because it is also a right angle triangle, to be able to get SC. Once we get SC, we will be able to use it and use BC to be able to get SB. So that is the procedure. So what we do here is we say, let's start with SC. SC, let's say this is part A. Let me use this space because of space I have here. So we can say we start with SC squared is equals to SR squared. You add to RC squared. So we have that. Now we already know our SR. Our SR is the width, so it is 6 squared plus our RC is 8 meters. 8 meters, sorry for that, 8 meters, that is squared. So this is equals to 6 squared is 36 plus 64, which you will be able to get, it is 100. So the square root, so it means SC is equals to the square root of 100, which is equals to 10. This means that SC is 10. SC is 10. Once you get SC, now we can use it to be able to get SB, and we say SB squared is equals to SCB is a right angle triangle, so we use the Pythagoras theorem. So we say SB, which is the hypotenuse, it is equals to SC squared, which we have obtained here, which is equals to 10. You add to BC squared. So this is equals to 10 squared plus our BC is 4 squared. 10 squared is 100. 4 squared is 16. So this is 116, implying that SB is equals to the square root of 116. The square root of 116, which you can use the calculator, and you'll be able to get the square root of that is 10.77 meters. So that is the length of SB. That is how you get that length. From there, let's go to the part B of the question. So we look at part B. We are told the angle between SB and the plane CDSR. So this is SB, that is the line in red, and the plane CDSR, the base of the tank. So the angle that we are interested in is that angle here, this angle. So we can use the trig ratio and say tan ATD, that is that is part C. Part D, we are supposed to say tan BSC, that is the angle that we are interested in, tan BSC BSC is equals to opposite, which is 4 over hypotenuse, opposite over that is opposite over adjacent. So it is 4 divided by our SB is 10, which we have calculated there. So we say angle BSC it is equals to tan inverse of 4 over 10. Using your calculator, you'll be able to get that angle is equals to 21.8 degrees. So that is part B of the question. Let's go to part C. Part C of the question. Let's use this space here. Let's minimize that space. We put it here. That is part C. In blue. Part C, we are told length AT. Where is our AT? AT. This line here, this one here, which I can be able to draw, that is AT. We can use a blue color to be able to see it properly. That is the line. So AT, we can draw another line here, which will join D, so that ATD is a right angle triangle. This is a right angle triangle. So we can use, because we want to find AT, we need to use TD and AD to get AT. But we don't know AD. We know AD is 4 meters, which is the height. But we can be able to get TD using ST and TD. So what we do here is we say TD. Let's do that. Let's change that. That is, we say TD squared is equals to, this line is the same as ST squared plus SD squared. That is using the Pythagoras theorem. So we say that is part C. We say ST squared plus SD squared. ST squared plus SD. So this will be able to get that is TD. We get it is 3 squared plus 8 squared, which is equals to 73. So we say TD is equals to the square root of 73, and you can get that using your calculator. You will be able to get 8.544. So that's how you get TD. Now that we got TD here, we can now be able to get, we are required to get the length AT. So we say AT squared is equals to, that is TD squared, which we have obtained, plus AD squared. So that you can be able to get. We already have our TD. Our TD is root 73 squared. Our AD is 4, so it is 4 squared. So this is equals to 73 plus 16, which is equals to that you'll be able to get, you add the, you get 89. So 80 is equals to square root of 89, which is equals to, the square root of 89 is 9.434 using your calculator. So that's how you get that is how you answer that part C, the length of 80. So the knowledge of the Pythagoras theorem here is very important. Finally, we have our D. Our D, we are supposed to get the angle ATD, this angle ATD. So we get ATD. Already we have got our, we can either use TD or we can use AT. So we say you use a trig ratio tan, that is tan ATD, that is ATD, this angle here is equals to opposite, which is 4, divide by the adjacent, which is our that is our TD. And remember, we got our TD is the same as the root of 73, or you can use 8.44. But let me use the root of 73 because it is okay. You use the calculator to do that. So you come and say angle ATD is equals to tan inverse of 4 divided by the root of 73. And when you use your calculator, that is, you press tan inverse, that is the inverse button, you press the button of tan, then you can use the bracket 4 divided by the root of 73. You will be able to get it is equals to that angle. You will be able to get it is 25.09 degrees. So that is the angle ATD, and that is how you work out that. So note that we have applied a lot of knowledge of Pythagoras theorem, so very important. And that is why in maths, everything that you run, you need to understand it, because here, if you don't understand the Pythagoras theorem, which we apply in right angle triangle, then you may not be able to solve this. Again, you should understand how to get the angle between a line and a plane, which we have said it is the angle between that line and its projection, where we have said that projection is actually the shadow of that line. So with that, I hope you have understood. So that is the end of lesson 1. You can have a look at this question. This is a Kcse question from the topic 3 dimension. Then you can, if you can work it out, then you can, if you can watch out for the answer in my video, which I'm going to create. So that's an exercise you can do. You can pause the video, pause and copy and write the question. Then you can go to this other one. It's also a question that you can use to practice on, and you can be able to watch for the answer. So from here, I'm going to do the second lesson. That is, we are going to learn how to get the angle between two planes.